Hello guys, my name is Balkrishna Shivastav and welcome to Code with BK. So in this video, we write a function in C programming to reverse a linked list. So before we begin, it is a request to please subscribe to my channel. And if any of my previous video or if this video helps you out, so please do subscribe to my channel. So in this video, we complete this function. The name of the function is reverse. It takes the head node of a linked list and returns the head node of the reverse linked list. Okay, it is supposed to reverse this linked list. All right, and we do this in a single pass. Okay, we traverse the linked list once and we do not use any auxiliary space. We complete the solution in constant space. All right, and in my series about linked list in C programming, I've covered linked list in very detail from the very start on what is a linked list, what is the idea of a node, how nodes are created, how nodes are connected to create a linked list. Okay, the idea that this struct basically is a node for us in a linked list, right? And then we saw operations like insert, print, and remove from a linked list. Okay, so for this problem, this is my struct that represents my node in a linked list. Okay, and this is what is used as a struct for linked list problems in C programming on LeetCode. Okay, let's begin. So suppose if I have a linked list with nodes like 4, next of 4 is 3, next of 3 is 18, next of 18 is 9, next of 9 is 100, and next of 100 is null, and let me make it all caps. Okay, and this is my head node. Okay, so for all data structures that we have, there are certain references that basically store / define the data structures. In linked list, the head is the most important because it points to the first node, which is the starting point of the linked list, basically saying that head pointer stores the linked list. Okay, now if we have to reverse this, okay, so reverse this, that is the order of the nodes. Okay, the order of the values have to be reversed. So my values are in order 4, then 3, then 18, 9, and 100. Okay, I want the order to be reversed so that 100 from the last comes first, then 9, then 18, then 3, and then 4, putting them into nodes. Okay, because we are dealing with linked list nodes. Next of 100 is 9, next of 9 is 18, next of 18 is 3, next of 3 is 4, next of 4 is null. Okay, so the order of the values is reversed. Okay, and we will use the same node. So for our solution, this node with the value 100 is this very same node. This node with the value 9 is very same node. Okay, we do not use any extra space, we just move the nodes around. Okay, so when you reverse this original linked list, you should get something like this, and this is your new head. Okay, your original head is still pointing to 4. Okay, which was the head of the original linked list. Okay, now how do we go about this is, let me just draw the original linked list once again. Okay, so for a moment, let's leave aside coding and let's see how do we approach this, right? So the idea is to not use any extra space. Okay, and to complete this in a single pass. So in one single traversal of the linked list, I should be able to reverse. Okay, I will say instead of 4's next pointing to 3, I will make it point to null. Okay, so instead of 3's next pointing to 8, I make it point to 4. Instead of 18's next pointing to 9, I make it point to 3. Instead of 9's next pointing to 100, I make it point to node with the value 18. And instead of 100's next being null, the next of 100 points to the node with the value 9. Okay, so the next of 4 is null, next of 3 is 4, next of 18 is 3, next of 9 is 18, next of 100 is 9, which is exactly this reverse linked list that we are looking for. Okay, and if I put my new head here, I have 100, the next of which is 9. Okay, the next of which is 18, the next of which is 3, the next of which is 4, the next of which is null, which is exactly what we want. Okay, so the idea is traverse left to right. Okay, and flip the next pointers. Okay, and obviously you have to make sure that you return the new correct updated head, and the next of the last node, which is the first node in the original linked list, has to be. Okay, now how do we do this? Let me just draw this linked list again. So at times I use lowercase null as well, it just means the same thing. Okay, now I have to complete this idea of traversing from left to right, flipping the next pointer so that I end up with the reverse linked list. How will I do that? I will say I'll take a new node pointer previous to null. Okay, this node is type def struct list node, so you can either type struct list node or you can instead type node. Okay, all right, So I have a previous pointer which is pointing to null. Okay, I will say my current will point to head. Okay, so I have another pointer current pointing to head. I will say while current, that is to say as long as current is not equal to null. Okay, I will say node next is currents next. Okay, then I will say currents next now is updated to previous. We move previous and current pointers forward by saying previous is current and current is next. Okay, and then we return updated head. Okay, let's just follow this piece of code that we have written. Okay, so previous is pointing to null, current is pointing to head. So after first two lines we have current pointing to head, previous pointing to null. Previous basically storing that. While current, condition is current is not equal to null. Okay, this is true because current is pointing to head, so condition is true. We move inside the while loop. Node next is currents next. We get a new variable next which is pointing to currents next. Currents next is node with the value 3, so we have next pointing here. Then we say currents next is previous. Currents next now has to point to previous. Currents next was pointing to the node with the value 3, now has to point to previous. So this next of 4 is now null because previous is null. Okay, so our first step of disconnecting 4 making its next to null works. Okay, and I've repeated multiple times in my previous videos before that when you do something like this, currents next is previous, it means pointer values are copied. So whatever pointer value is inside previous is copied to currents next because they are of the same type, which essentially means to say that currents next points to the node, the struct node where previous was pointing to. Okay, in this case it is being. Then we say previous is current. So value of current is copied into previous, that is previous points to where current is pointing to, previous points to where current is pointing to. Okay, and then we say current is equal to next. So current points to where next is pointing to, next is pointing to the node with the value 3, current points here. Okay, so the next of the 4 that was pointing to 3 is pointing to null, current is pointing to 3, previous is pointing to head is no more null. Okay, and your head is still in the node with the value 4. Okay, so essentially you have right now 4's next is null. Okay, head is pointing to this. Okay, we have previous also pointing to this. We have 3, 18, 9, 100 and null. Okay, the remaining linked list where current is pointing to 3. Okay, and after the body of this while loop is over, you lose variables which went out of scope, which is next. Okay, so after first iteration we have something like this: 4 next is null, head is pointing to 4, previous pointing to 4, current is pointing to 3, and 3 is 18, 9 and 100 and null. Okay, we go back to check for while loop condition because body of the loop is over. Current not equal to null is true, current is pointing to the node with the value 3, so this is true. Okay, you say next, a fresh variable next pointer is equal to currents next. Currents next is this, so this is next now. So after this line we have currents next is previous, currents next is pointing to the node with the value 18, this is lost and it points to previous which is node with the value 4. Okay, then we say previous is current, previous now points to this node with the value 3 and current is next, so current points to this node with the value 18. Okay, so after the second iteration you have 4's next is null, head is still the original head that we got is still pointing to this node. We have 3's next pointing to 4, we have previous pointing at 3, we have current at 18 pointing to the node with the value 18, next of which is 9, next of which is 100, next of which is null. Okay, and next we lose after the body of the loop is over because it went out of scope. So after this last line in the while loop, we go to check for while loop condition, current not equal to null, current is pointing to this node with value 18, true. Okay, node next is currents next, so we get a fresh variable next pointing to this node. Currents next is previous. Currents next was pointing to 9, now points to previous, which is a node with the value 3. We say previous is current, previous now points to this node with the value 18. Current is next, current points to this node with the value 9. Okay, so now what you have is 4, the next of which is null. This essentially is, then next of 3 is null, this node with the value 4. Next of 18 is node with the value 3. We have previous at 18, we still have head at 4. We have next, next is lost after the while loop is over. We have current at 9, the next of which is 100, the next of which is null. Okay, after the third iteration the loop ran 3 times. We go to check back for while loop condition. Current not equal to null is true, current is pointing to this node with the value 9. Next is currents next, so we get a fresh variable next. Currents next is previous, currents next was pointing to 100, current is at 9, the next of 9 was pointing to 100. It points to previous now, which is the node with the value 18. Then you say previous is current, previous now points to the node with the value 9, and currents is next, so current now points to the node with the value 100. Okay, so now after the fourth iteration we have next of 4 is null, we have head pointing to 4, we have next of 3 as 4, next of 18 as 3, next of 9 is now 18, we have previous pointing at 9, we have current pointing at 100, and the next of which is null. After the fourth iteration we lose next because it went out of scope. Okay, going back to check for while loop condition, current is pointing with the node with the value 100, true. Next is currents next, so next is now null. Okay, currents next is previous, currents next was null, which now points to previous, which is node with the value 9. Previous is current, previous moves on to this node with the value 100. Current is next, so current now becomes null. Okay, so after the fifth iteration, the loop ran 5 times, 1 2 3 4 5. We have, this is essentially 4, the next of which is null, then next of 3 is 4, next of 18 is 3, next of 9 is 18, next of 100 is 9. We have previous at 100. Okay, your head is still at 4, we lose next, and current is now null. Going back to check for while loop condition, current not equal to null is now false. We come out of the loop and we have to return the updated head now. So your list is reversed. We have hundreds next as 9, next of which is 18, next of which is 3, which is next of which is 4, next of which is null, which is exactly what we were looking for here. Okay, 109, 18, 3, 4 null, 109, 18, 3, 4 null. Okay, so what is the updated head in this case? Previous. So we can say return previous, and this is your code. Okay, so let me just quickly code and test this. We have node previous starting at null, we have node current starting at head. I'll say while current is not equal to null, this is equivalent to saying current is not equal to null. In C and C++, if you put a pointer value inside a while inside a loop condition, it can evaluate to true or false. So if this pointer is null, the condition evaluates to false. If this pointer is not null, the condition evaluates to true. Okay, so we say node next is currents next, currents next is previous, previous is current, current is next, and we return previous. All right, so in order to test, I have written 2 helper functions, one to print the linked list and one to create a linked list out of these values in this array. Okay, all right, so you can have a look if you want. Okay, so if I have say 5 values in my array and I pass 5 as the number of values, and then I print the linked list, I should get 1 2 3 4 5. So clear, compile, run, I get 1 2 3 4 5. If I update this value, say 90, 21, 50, 55, say 41, 39, and say one more value, say 100, and I make it 6 values now, right? 336. I should get a linked list accordingly. 90, 21, 55, 41, 39, 100, the order in which I pass the values in my array. This is an anonymous array. Okay. All right. So let's just pass the set of values that we have taken: 4, 3, 18, 900 null, 3, 18, 9, and 100, and we have 5 values. So after I print this, I should get my linked list: 4, 3, 18, 900. Okay. All right. Reversing this, I will say the updated head is now after reversing, passing the head of the original linked list and printing it again. I should get the linked list in the reverse order. So I get 100, 9, 18, 3, 4. Okay, the way we expect. All right. If I add as a few more values, say 4, 3, 56, 18, 7, and 99. So these are 3, 3, 6 to 8 values. Okay. So I should get my original and reverse linked list accordingly. Okay. 4, 3, 56, 4, 3, 56, 18, 7, 999. Okay. So the corner cases that you can think of is if head is null, you simply return head. Okay. All right. If the linked list is empty, we do not do anything. If the linked list is empty, return the list as it is. And you can take one more case, that is or head dot next is null. That is, if there is a linked list, if I get a linked list in my function that has only one single node, so the reverse of the linked list is going to be the same thing, one single node. Okay, so I don't have to do anything, I just return the head as it is. Okay, or if the linked list has only one. Okay, these are the cases where the linked list has more than one node. Okay. All right. So we can check for single nodes now. So if I just pass 4 and one node, clear, compile, run, 4 and null and 4 and null, same thing. Okay. 4, 3, 2 nodes, 4, 3 null and 3, 4 null. If I don't pass anything, say 0, okay, null and null. Okay. All right. So this was your C code to reverse a linked list. All right. And we used one single pass. Okay. And we did not use any extra space. So constant space as well. Okay. All right. So I hope you liked this video and this was helpful. If there is any doubt, there's a part you do not understand, please let me know in the comments. I always try to answer all your comments. And you can also let me know in the comments if there's a question you want to solve or if there's a concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.